Okay, grade 11s. Today we are looking at how to solve trigonometric equations and what that means. First of all, it will help you a lot to understand the following. For any function like sine, cos, and tan, the trigonometric functions, it is a continuous function. It continues and goes on in both directions. This does not stop. So when I'm asking a question like this, for instance, this is now the sine graph, and we know this is x and that is y. If I'm asking you for which values of x is sine x equal to a half, can you see that in asking that question you will have an infinite amount of answers? Let's say that represents a half. Can you see that it will have many answers? Like over here, we know that sine 30 is equal to a half, so this will be 30 degrees. That will be 30 degrees, that will be our first answer. But 360 degrees later, that means at 390, we will have the same answer again. It will also be a half, and so on and so forth. And even if you go in this direction, this will be minus 330. And you can see I'm using the points that are in phase. So, and this will continue. You'll have an infinite amount of numbers on both sides. Okay. But now there's a second answer as well. And if you remember your cast diagram, you will remember that this would be 180 minus 30. So this would be 150. At 150, you'll also have sine 150 equals to a half. And this value will be repeated in phase again. So 150 plus 360 is 410, right? So now, 510. You'll have another answer there, and if you go in the opposite direction, over here, you'll have another answer. And as you can see, you've got infinite amount of answers. And this is why it is needed for us to have something called a general solution and a specific solution. Okay, so the function does not change, right? But if I ask you for which values of x will we have sine x equals to a half, where x lies between 0 and 360, can you see that what I'm actually asking is I'm taking a section of this function and I'm only focusing on this section. So within this section we'll only have two answers, 30 and 150. That is an example of a specific solution. But the general solution means we need to write it in an expression that will include all the answers to the left and to the right for both cases, for both areas where it takes place. So I'm just quickly going to work with the cos graph and the tan graph as well. But if you think about the cos diagram, before I move over to the cos graph, you need to understand that for a sine graph, the first and the second quadrant will be of importance if our value is positive. If the value is negative, the function value, the third and the fourth quadrants will be of importance. But we'll get to that the moment we work with examples. So let's look at the cos graph. Here you have a cos graph, and again the same thing will apply now. if we are looking for a specific answer or a general solution to a value, we can again say a half or square root of 3 over 2, doesn't matter. But you will see that you have two answers within 360 degrees, which will be that one in the first quadrant, that one in the fourth quadrant, but it will be repeated. This one will be repeated in phase all the way through, and that one will be repeated in phase all the way through. So again, we've got the same pattern. We've got two answers, and it goes in all directions. What will be of importance here with your cos diagram? With the cos function, it is positive in the first and fourth quadrant. You can clearly see that there. Again, if I would draw a little window now of looking at a specific solution, you will see that we'll have an answer there and there. So this should be just in the first quadrant. This will be 360 minus theta. You'll get your answer over there. If it's negative, it will be in the second and third quadrants. But again, we'll get to that a little bit later. Let's look at the tan graph. So if you look at the tan graph, you'll see the same thing. It's a pattern that repeats itself. And but in this case, please have a look that if I draw a line now through this graph, the tan graph is a little bit different. It will have one position in phase being repeated. The difference though is that this is only repeated with every 180 degrees, not 360 degrees. You can see here, if I take this part of the function between 0 and 180, and I use that and I copy it and I paste it, it will be repeated in both directions. So for a tan graph, we do know that if you think about the cast diagram, that a tan graph is positive in the first and third quadrants. But that is because the third quadrant is a repeat of the first quadrant over here. Here's our first quadrant, 0 to 90. Second, 90 to 180. Third, 180 to 270. It's exactly the same as the first quadrant. And then the fourth is the same as the second quadrant. So for tan graph, we are only looking at what happens every 180 degrees. And this will come out in the examples as well. So just again to explain the difference between a specific solution and a general solution. A general solution is writing down an expression that will tell you what the answer is for this function for all values. A specific solution is basically taking a section of the graph and only focusing on that to say, well, if x lies between 0 and 180, this value will be the answer. And that's how we're going to look at it. So this is introduction to trigonometric functions and equations and how the solutions will work. I'm going to post 3 videos working through examples with general solutions and specific solutions. Those are very important. Please go through them as well.